Okay, welcome back. Hopefully everyone's fed and watered, ready for the next session. We're on the home stretch. Okay. So it feels like there's less people, but it might just be there's still folks downstairs. Right. Okay, I'm going to introduce our next speaker, Jonathon Stelling. Jonathan's talking about modernizing maintenance. He's a project manager at Omnicom and leads web and system software teams in developing track geometry systems and RAVE data visualization products. He's recently collaborated on the success of UGMS systems on Hitachi fleet across the UK, which will help to collectively capture over 2.5 million miles of track geometry data every year. Welcome, Jonathon. Yeah. Okay.
Yeah, everyone hear me okay? Great. Good afternoon all. I hope you've enjoyed the presentation today. I know I have. Had a great lunch. Thanks for having me. So my name is Jonathon Stelling. I'm a product manager, as introduced at Omnicom. I'll touch on, I guess, the transition that we've got moving away from Balfour Beatty to Hitachi Rail, as announced earlier this year. So strategically, something where that move over to Hitachi, away from Balfour Beatty, I think is going to be reflective in the slides where we have developed track geometry systems to be used unattended systems on passenger vehicles on Hitachi fleets. So I'll touch a bit about that on the next slide. I'll talk firstly about where the industry is with attended systems with the IM Yellow fleet. We'll get a nice picture up and we'll have a guess at which train it is. It could be NMT, it could be PLPR. I always get to see one of them in York Station whenever I'm there. And then we'll talk a bit about UGMS systems, how Network Rail has, since the early 2000s, wanted to strive to get passenger vehicles equipped with UGMS systems. And we'll talk about how we introduced those in 2012, but only very recently those have started to go through validation. As we've touched on, it does take a long time, sometimes in rail, for innovation to get into practice. So we'll talk a bit about that, and then we'll talk about it in use today and how routes and regions are using that to use and maintain the track with that data. So I'll touch on a bit about Balfour Beatty and Hitachi and that move. Omnicom as a business has been around for 25 plus years, developing systems to monitor predominantly railway infrastructure and their assets. So I'll be talking about today track geometry and things like that. But Omnicom has developed gauging and other surveying products as well. So it's really seen, I guess, the industry, the change over the years, and we've been along that journey as well. 2 offices, one in York, where I'm from, and then there's one in Derby as well. So it's, I guess, two big hubs of rail. And not only in the UK do we have systems, we've got systems, like, say, Spain, other areas of Europe, Australia, and then moving into Asia as well. So I guess where it all started probably 15, 20 years ago and is still present today as well is the attended systems. So this is 6 to 7 dedicated fleets of vehicles, 6 to 7 dedicated vehicles which run around the UK, fleets which them that are maintained, and there will be crews which man these, and on-train technicians which will ride on the shifts. They'll check over equipment before it goes out to run, make sure everything is set up and maintained, and when it goes out to run, they will load in journey files for position systems, so they'll make sure that they're covering and going along the track which they're planning to record today. They'll go through that, and they'll look at the data, and they'll look at that in real time. They'll call off any immediate action faults as severe as block the line, and what we'll do with that information, they can call that through. So the benefit of that being an attended system is that you're seeing the data in real time, you are seeing those issues in real time on the track, and you can call that off. So yeah, as I said, 6 or 7 of those vehicles, I believe, it could be NMT, it could be one of the PLPRs. But taking NMT, for example, would typically cover around 110,000 miles of track a year, so a significant amount of track. In any one day, you could cover up to sort of 15, 16 hours. You've got multiple crews which can be on those vehicles. There's a lot of planning which is involved in that. You've got to understand where the train's going to start, where it's going to end, where crews are going to switch. Is there going to be a space on the platform where we can fit between a passenger vehicle, and things like that. There's a lot of things to consider around an already very busy network running and moving passengers around the UK. I'll touch briefly on, and this reflects what attended systems would do as well, but unattended systems, an optical system, so it's an optical based system with a camera and laser, intrinsically and extrinsically calibrated to look and take a cross section of rail, and they would calculate a rail corner, pair that with inertial data, which will then generate your traces for all types of track geometry, from gauge, twist, cross level. And what we see on the screen is that they are the pods which are used on the Hitachi fleet. So you've got a dedicated camera and laser which are over the left and right rails. You've got some aerofoil designs on the bottom, so they manage the airflow going over the lenses, and it's one of the things we'll touch on is lens cleaning and keep making sure that data is good. We're collecting a lot of data. We want to make sure the data is good. So it's one thing to keep in mind. It's thinking about that infrequent maintenance, because they're on passenger vehicles. Passenger vehicles, they will come in typically once a month, and they've already got a lot of maintenance. There's a lot of other systems which are on the train which need to be maintained. So keeping maintenance on our systems to as little as possible is what we try and aim for. In the background, Network Rail from the early 2000s have wanted to have UGMS systems really on passenger vehicles, and the benefits for that really are that they're already running around the network. You don't need to find vehicles maintained for 30, 40 years. I think as explained earlier that they are in service for a long time. Let's use what we've already got on the network. We don't need to plan around those shifts. We can, as long as we strategically place the systems around the UK network on the trains, and making sure that those vehicles, they are still tailored towards maintaining that passengers are getting to where they need to go, maintain service, and they're not cancelled. We also need to make sure we're still collecting data as well. So there's a lot of communication between Network Rail, ourselves, Hitachi, making sure that we've got the right trains in the right position, collecting data. But really, that's the benefits are they're already out on the track, and we need to leverage that. So a case study really on what I touched on earlier. So we installed the systems back in 2012, and it took many years for us to get to a position where we had a service level agreement in place. So where we could maintain the systems, we could manage obsolescence. So the systems, for example, Windows operating systems look very different in 2012 to what they do today. Other technologies like antennas for GPS and things like that have all moved on and needed to be upgraded. So as we sort of got towards 2020, those systems went through overhauls, were upgraded, and then near the end of 2022, the start of 2023, we had our first system validated by the TA, Technical Authority at Network Rail. and we've ever since we've been upgrading those units. We've got around 15 over the UK, so we cover the East Coast Main Line, so the Trans-Pennine Express route. So David Woods has been getting some good information. He tells me regularly. We've also got the Great Western and the West of England as well. So like 4 of the key routes in the UK we collect a good amount of data for. And it works out to be around, I think when we worked it out annually, 2.5 million miles of data a year is a lot of data. So we need to make sure we're collecting good data, and really for users hiding the data that they don't really need to look at or worry about or question, is that correct? Should I be looking at it? We've also got more systems to come as well. We've got some on AMER as well. We've got 4 of those systems. There's also a few have been asking questions about the Crossrail and Elizabeth line. There are 3 systems on there as well. So those are delivering data, not only track geometry, but overhead line data as well. So some of the challenges, and it's with existing fleets, I think, going forward, it would be great if these types of systems were developed with alongside vehicle development, so you can understand size envelopes and where it will be best positioned, so you can negotiate where you like those to be positioned. Unfortunately, we're not always in that position. We're given a vehicle of which we need to design around, and different vehicle manufacturers have different vehicles, so it brings different challenges and new projects. So we've always got to make sure we fit within those requirements. We're very close to rail, mounted on the bogie, so it's great from a perspective of where you would always like to capture the rail, make sure it's always in view of the camera, so as the vehicle moves, we're always capturing the rail and it's not moving out of sight of the camera. But being so close to the rail, you're going to pick up a lot of dirt. So we touched on that, and alongside Hitachi and ourselves, we'll be maintaining and cleaning those lenses. Within the contract when that was originally set up, we agreed that every 56 days we'd look to clean the lenses. But looking at the data, going through the seasons, it appeared that it was around 30 to 35 days was the sweet spot of where we would say we have gauge and cross level 80% of the time. Anytime we drop below that is where we want to have lenses clean, so we want to keep that up. So when users are looking at the data, we want to make sure that it's any less than 80%, we just hide the data. There is a vast amount of data going into RAVE, which we'll come on to. It shouldn't be confusing and overwhelm users the amount of data. They should be easily able to jump onto the data and make use of it. One of the use cases I'll touch on, so this is on the Western, cyclid top is of, I guess, a real topic at the moment. This was a fault which was near the end of last year, and there was a LinkedIn post you may have seen. There was a Yellow Fleet vehicle which ran over there and had a cyclid top event. They were able to maintain the track, and because we had only a temporary speed restriction in place on there, we still had passenger vehicles going over there, and we had a UGMS system on there. Didn't need to wait for the Yellow Fleet vehicles to run over there, so we weren't waiting another 4 weeks to get the data to prove we have maintained the track. We have a passenger vehicle which has run over there and has collected the data and said the track looks good. After that improvement, we can look to remove that speed restriction. So it means that the temporary speed restrictions that are put on there, passengers will still see that delay, track will still need to be maintained, but we can reduce that. We can remove the number of cancellations and just generally have passengers as at priority. I'll now touch on RAVE. So RAVE, and many people ask what RAVE stands for, and like for many software names is a recursive acronym. RAVE, the R stands for RAVE, and then after that, analyze, visualize, evaluate is what we expect users to do with the data. So it was developed by Omnicom, and important to note, and we touched on the Elizabeth line, not only displays track geometry, will also display overhead line data and any other data which can be positioned on a network model, we can display in RAVE. So it's not limited to track geometry, and we'll come on to that a little bit later. And some of the things I'll touch on. So I'll talk about how routes, they don't need to know where trains have ran to look at data. They just need to worry about their track. Where is my track and what's run over that, so they can search for an area of track and then pull data from the database and see that. Automated validation. So at the moment, there are still, and it's potentially one for the panel discussion as well, is that there's still a lot of change, and this is very new, UGMS systems, and it's thinking about how will that data continue to be validated alongside the yellow fleet vehicles. Historic data sets, capturing a lot of data, we store a lot of data and keep it, probably go back at least 12 months so we can get those before and after pictures of maintenance on the track. And then collaboration as well. So it's really easy because it's a web product. You're able to just share links with colleagues and over Teams and email and show them what you're looking at in RAVE. Here's just a view of, say, the search function. So it's when the data lands into RAVE. I think in there I've searched for ECM5, so just north of York Station. I can search for that with a mile. I can find the drop-down list of data, and then in the top right, so we talked about lens quality as well. Is the lens, are the lenses dirty? Are we hitting at least 80% of data? So we can toggle that at the top. So it just hides from that drop-down list a lot of data, which potentially might not only cause confusion, but ultimately just delays being able to get to the results that you want to see. Is, has my track either deteriorated or has it improved? Automated validation as well, and actually, where is that track located? Its peak exceedance, action text, how quickly do I need to action it as well? So things which RAVE would generate. So when the data comes into RAVE, because it's not all done in real time, if there are issues with positioning of the data, RAVE can reposition the data. So if you have a dropout in GPS, you can take other data feeds. So where in the network model, we've mapped berth locations, we know where the head code of a train has ran through those berths. That helps us with positioning the data post-processing. So if we take Wednesday's data, and then RAVE will be looking at bringing it in this morning, today, so it will be available the next day to the user, but it allows for those positions to be corrected, which is great. So yeah, historic data sets, and we've touched on it about it's looking for times where you've got track deterioration, or you like to have some before and after information about improvements to track. Can all be used, and where we like to take RAVE in the future is be able to trend and predict. Ultimately, it's getting that right, but it starts with the data that you collect. It's very hard to trend data which is bad, so you need to make sure the data is good that's going into it. So yeah, making sure as you're coming along that journey, you're getting things right, get really not to that stage. Collaboration as well, so just the copy URLs either in the top or the top right, as well as being able to export charts as well. Some of you may be familiar with the charts which are generated from the yellow fleet, so we can also produce those in RAVE. We can generate overlays as well of multiple runs as well, up to around 5. I think any more it almost becomes unreadable within the PDF chart, but we can take those offline. And sometimes say print them out, and sometimes it's just history that people do like to just go back to pen and paper and look at those traces. Where we like to go with trending, up on the top left there, and grouping of exceedances. So back with the attended workflow, where you would have each shift Each exceedance is almost specific to that recording, but where we're able to group exceedances together, we can then start to see that trend. Is my exceedance getting worse? Is it stable? It's not going to be improving by itself, but have we done some work on it recently, and can we look at that? So we can show things to users such as when did it first occur, what was its earliest action text, how severe is it at the moment, and it's most important, do I need to do anything with it at the moment? And where that would be available to users is that they would have their dashboard with an area of track, a route that they're held responsible for, they need to maintain. That would just be available for them, so they wouldn't need to worry about the rest of the UK network. It's just an area of track which they can get statistics on and notifications on. One final slide of new features to end on would be combining that with the line scan imagery. So if we can position that alongside UGMS data, we're going to be getting volume reporting. At the moment, the systems generating imagery would be on the yellow fleet, so it's making sure that we're matching up the dates of that imagery very closely with track geometry. But it'll be looking something like this, so it's making sure that you're not cluttering the screen with too much information, just making sure that the imagery is clear and so are the traces as well. And one final slide to end, I think quantifying some of the savings that have been seen already from boots off the ballast and actually from reducing delays and removal of some of those, or reduction in fines, has resulted in around a saving of £500,000, and I think that is only going to grow as these systems across the Hitachi fleet become validated. I think one thing to take away would be, and working on the project with Network Rail and Hitachi has definitely been collaboration, working together, understanding different people's, different companies' drivers. I think really does help just to deliver. And I think, it's like with the lens cleaning example, I don't think we would have got there without collaboration. We wouldn't understand the pain points from Network Rail, understanding the pain points from Hitachi and their maintenance schedules, that they need to still ensure that they're getting vehicles out on time, and they're maintaining all the other systems that they've got on there. It was getting that balance right, but ultimately it came down to collaboration and speaking to people. So that was one thing to take away today. And that's me. Thanks for listening.